Welcome to our journey through the cosmos. We embark on this journey in order to create a space scene. I wouldn't call it a believable space scene. I would instead call it a cinematic space scene and a cinematic experience, experience that you can put in your game if you want to, or just simply, whip out a ship and just sail through the stars. But I want to help you get there, get to that sort of realization of that world that you can traverse a lot quicker. I've actually seen some people on YouTube who have used some of my project files to put them inside, to use them to create their own content and have ships, moving around through space. Now, I must say, these project files that I've got, this one that you're seeing right now is available on ArtStation or on Gumroad or on my Patreon to get. I will be giving you the Nebula that you're seeing right here. You're seeing on the screen. You will be able to, well, you can call it a nebula, you can call it a galaxy. I mean, they're not the same thing, but they can definitely mean, they can be for you. You can use them as galaxies, you can use them as gas clouds. I'm going to show you how to create them, and then you can get this Niagara system for free. There's a link in the description below to get it for free. But if you want the full project file, you can get that off of ArtStation or off of Gumroad, like I've said, or Patreon. There's also a Discord channel link in the description that you can join, where you can ask me questions and I can help you. I can give you feedback. I can pretty much answer anything that I've got knowledge to, anything that I've got information on. I will try and help you guys to on your own projects and to learn, and hopefully I will learn some things along the way. There's actually been quite a few people on Discord that have approached me to help them with their scenes and with their projects, and I've learned a few things doing that, and especially I remembered some things doing that I forgot, which was quite interesting. But yeah, as I've said, this is a journey that we're going through together. We're learning how to create space fair objects, planets, planetary systems and all sorts of things. And I'll be developing this even further and create more and more project files and more blueprints and all sorts of neat tricks of how to put together the space scene. So, and you're always going to find this content available and quite cheap as well. Again, it's the price of a coffee. If you want to buy me a coffee, I do like a nice coffee, then feel free to pitch in. So let's begin the tutorial, and hope you enjoy it. Please leave a like, a comment, and subscribe, as I always read your comments and I always answer to them. Thank you. As per usual, we want to start deconstructing the scene a little bit, because we're making this part over here, this vortex. We're going to have a look at how the Niagara system is set, what the material is that is allowing it to look this way, and then also just going a bit through the blueprint, but that's nothing fancy in there. It's the Niagara system that's driving most of this. So if we actually select Edit Blueprint, this is the blueprint right here. I'm just going to make this a bit bigger. So when we have a look, if we select the nebula into the blueprint and we double click it, this will open it. And now you're seeing that we've got 3 elements in here. Now, let me just drag this a bit to the side, like that. And what you'll notice is if I, for example, deselect the first part, that is the big chunk of the effect. So that was the entire vortex, really. The second part is these sort of shiny lights that you're seeing around here. Basically, this effect is this vortex nebula type thing. You'd be able to put it somewhere in the distance, and then you would have these sort of propagating towards the center, which would then look quite nice. But obviously, in this particular instance, I'm using it to put some emphasis on this planet core over here. And now the third part are these Niagara driven asteroids. So if I deselect them, they will disappear as well. So we will focus mainly on the, well, we'll do all three aspects of this, but this first Niagara system, this first spawner, emitter as they call it, is the one that we're building everything around. One important thing to note is that it's using a mesh so I'll show you the mesh over in just a second. They're using a Galaxy Torus, I called it. This is something that I created in Blender. So it's this sort of shape in here that you're seeing, and this is what drives that effect of how the particles are being spawned. We're basically using the geometry of this mesh to pretty much coordinate where the particles will spawn, along what sort of path as it goes around. You'll see some fluctuations in FPS as I look at the scene, and this is mainly to do with me opening the blueprint of the particle system and also the system itself, which is then sort of getting our Unreal Engine project to overcalculate things, and especially if you're not having the window into focus, then the FPS drops as well. Anyway, but it doesn't matter. As I said, in playback, that's not really an issue at all. So what we're going to do is we're going to create this shape in Blender very quickly so I can show you how that's being done. So then we can move on to bringing the shape into Unreal Engine and then start building the system. Now bear in mind that the shape can be vastly different. I mean, these shapes in the background are actually just a cone. So they're just a cone shape. And you can see what the cone shape is doing, what effect that the cone shape is creating. And this is just the sort of mesh that I've made because I wanted to look more, interesting, so to speak. But yeah, let's go in Blender and let's quickly do this mesh, and then we'll head back into Unreal after that. So the nice thing in Blender, if you're actually in the default layout, the nice thing in Blender is that you can create a torus pretty much instantly. So all we need to do is Shift A and then go into Mesh and select Torus. And there we have it. It's a torus. It's something that we can use. What I would do first is just go to the Modifier tab and add a subdivision surface just so we can give it a bit more geometry. Also in Object, you can change this to Shade Smooth so it looks nice. One other thing you can do is add a Displace modifier. And as you can see, this is really just pushed it all out like a very puffy donut. We don't want that. But we can press the new button over here, which adds a texture. And if we press these buttons over here, it will take us to our texture, or you can just press this button down here, which opens the texture menu. So then in here, we can select, for example, clouds, and you can see that it's distorting the mesh based on that texture. You can then play around with the strength a little bit. Now, the reason why I'm doing this is because I want some variation. It is just creating sort of areas where the vertexes will just overlap with each other, thus giving us a bit more chunkiness to our effect. So also another thing that you can also do is increase the subdivision level a bit more, or take this one off, add a new one, and keep it down here, and it just smooths out this this place that we've added earlier. Now again, you can still play around with the size of the clouds. You can even select different kind of textures, so a musgrave or marble. But I'm just going to Voronoi. Yeah, let's just go with a Voronoi one. That would be interesting. Now, one thing that we can do is scale on one axis if you want to. It's really all dependent on what sort of shape you're looking for. And then Shift D to duplicate it. And for example, if we go into the Y view, so pressing the Y over here, you can now rotate. So R to rotate, and then just if you hold Control, you can do it by angles. So you can do something like that, and then scale on the pressing X on the keyboard allows you to scale on the X axis, for example, like that. And then maybe you want to scale on the Y axis as well. So we created this massive sort of shape here. And you can just keep on going with this. So, duplicating again and putting it this way. I don't know, just whatever sort of shape you want to make. Again, it's not really, I mean, it is important in the sense of it obviously will have an effect on how your entire sort of structure will look like, don't get me wrong, but it's really, you've got to play around with these until you get something that you're happy with. So let me just try and duplicate it again, scale it down as well. One thing to note is that it would be quite nice to have a look at this and select all of them, do a Control J to basically get them all to merge. But if you do that right now and you have these subdivisions, sorry, these modifiers on, they will pretty much they'll basically multiply as you merge the meshes. So you do want to go in here into object and convert to a mesh, which then applies that. So this particular mesh has it all applied. You can do this same sort of operation to all of them, or you could have just done it to the original one that we started duplicating, and then this would be far easier. So I'm just going to I think I've converted that to something else. So, or you can just go up over here as well and apply the modifier. So Control A applies the modifiers. There's multiple ways of doing the same thing. Blender is very good in that respect. Now, if we Control J, so we've now merged all of them into one object, and we press N on the keyboard, we can see their dimensions. So it's not a very big mesh, but when you import it into Unreal Engine, you may want it to be fairly big. So we can just, if we press the left click on X-axis and then just drag down, we'll select all the axes and we can increase them. And as you can see, the scale also goes up for all of them at the same time. So we'll just use this mesh for now, but obviously you can make one closer to what I had in the original design, or we can use that if it doesn't look good, or we can come back into Blender and do another one if we want to, but we'll use this. So let's just press File, Export as an FBX. I'm just going to put it somewhere in here and just say Galaxy Torus. Make sure I've got selected objects clicked, and then Export FBX. And that will, now we can go back into Unreal Engine and import it so we can start working on our Niagara system. In Unreal Engine, we're just going to go a bit more to the right. I just hate whenever I deal with particles. If you go away from the main window, then the particles just start to drag the system down. So yeah, anyway, but we'll just click the content browser and open content browser 1. And then over in here, we'll just make a new folder and do like a tutorial folder. I'm just going to double click it. Then over in here, we want to import the mesh that we've created earlier. So it's this Galaxy Torus. We can make it as nanite, that's fine, it doesn't really matter, so we'll import it. This works, by the way, in Unreal Engine 4 as well, so you don't have to worry about whether or not this will work in Unreal Engine 4, or, you know, it's the same. So we've got the Galaxy Torus, and now we can right click in here and add a FX, which is the Niagara system. We can select the Niagara system, and over in here we'll do a new system from selected emitters. Go next. We want to make it as empty. We don't really need any sort of anything in it specifically, so we'll add that and press finish. And then I'll call this NS tutorial, I don't know, Nebula, let's call it that. Okay, and we can now double click it, which will then open our system, our new system that we just created. And with that open, we can now start adding nodes to it. So we're just gonna go and press the window button to bring up a preview if you don't have it. For me, I generally disable the preview, but I've just brought it back in, and you can see there's nothing in here. Now, what we want to do is, the first thing, we can select the emitter state and have a look to see what sort of system we want. So for this particular event, we'll leave it to lifecycle mode system and scalability to system. And we want to add a spawn rate over here. So let me just select it. And now the spawn rate is very much dependent on what kind of an effect, you know, how many particles you want to have, or how many times you want them to spawn. So to start off with, let's just go with, I don't know, 10,000 particles. And you can see that all of these 10,000 particles are actually spawning in here right now. So I'm just going to pause this Niagara system if we don't need it to run. But that's where they've all spawned, 10,000 particles. We're going to start moving them about as we go. Right now they're just spawning into one place. The next thing, we've got the initialized particle, which is basically this is the area that's going to help us set the size of the particle, the color of the particle, how long their life expectancy is. So in this particular case, we'll just leave it at 5 for the lifetime. Color mode will move it over to direct set. But then just leave it like that for now. And then we have the sprite size mode, and we can put that over to uniform, and then we can select how big these particles can get. And in, we're talking about planetary scale. So for the time being, we'll just leave it at 10, but then we'll increase this as the system develops further. Now the particle update is where most of our stuff is happening. So particle state, you will leave it as kill particles when their lifetime is over. So these particles die pretty much every 5, I think these are seconds if I remember correctly. So every 5 seconds or every 5 frames, I'm not sure exactly. Anyway, but they die after that, and this is important because if they wouldn't die, then you're with the spawn rate constantly bringing more particles in, basically your system would crash because you would be spawning particles forever if your lifetime, for example, was infinite. So you got to be sure you know what you're doing when you're adding these things, or if you're limiting the particles to a set amount of how many can be spawned at any given point. One thing also to note is that in the emitter properties, you want to select fixed bounds and change this to a GPU compute simulation so that it's it's not using the CPU to calculate this particle system, but instead using the GPU, which will give you more performance. Okay, so particle state is fine. Now the next thing we want to do is we need to set up our, we don't want to bring in any forces yet, like vortex or anything like that, because there's nothing there to move. But instead we want to bring the shape of our system, and that comes into the particle spawn. Into the particle spawn side of things, where we're going to spawn it based on a mesh. So in this particular case, we're just going to have to create in the ScratchPad the entire system that drives this function of generating our particles across a mesh. So we'll do that now. Over in here in the particle spawn, we'll click the plus button again, and we'll select a static mesh location. And this will have some errors, and you've got this button here, fix issue, so just press that and it will automatically fix the issues. And you'll see that now we've got a preview mesh and a default mesh where we can actually load the galaxy that we created. There's obviously some warnings in there, but we don't yet want to, so if I press compile, I think the warning will not disappear until we've actually brought in a mesh. But there's no point in assigning yet the mesh because we haven't yet created the rest of the stuff that's going to drive our, well, actually, you know what, we can bring the mesh. Yeah, there shouldn't really be any reason why we can't bring the mesh over. So let me just get the content browser. And if this would actually respond, I can now drag the torus in here, the galaxy torus. So I've got it in there, nothing really happens, but that's fine. If I fix now the issue, you'll see there's no longer an error, so that's fine. One other thing we can also do is, let me just drag this to one side. I can actually, let me just bring the content browser back. I can drag our galaxy in here, okay? And as you can see, this is everywhere. If I press F on the keyboard, but this is why it's moving so slow, because I'm too close to it. So I'm just gonna try to get too far away. Honestly, every time you don't look at the viewport, you know what I'm gonna do is I'm going to disable these other particles. Yeah, that's what I'm gonna do. And yeah, you see, and that's fine. Okay, so this is where we've got it over in here, and you can see that the particles are spawning across around the mesh, but unfortunately it's so small. It's very small. That's another problem. So Let me just try and reduce the speed of the camera that I'm moving at. But this is a very small system. So this is what it looks like right now. It's obviously going around the mesh that we created, which is great. That's what we wanted. Okay, but just imagine every time you scale this up or down, you'll have to account for the fact that because you've now scaled the mesh, the system, the particles will also need to be scaled as well, and all the vortex forces and everything else will need to be changed. So we've got the mesh in there. We're just going to go to our ScratchPad, and we're going to select the modules in here. Press the plus button, and we can call this Nebula. Okay, and this is the basic setup for the ScratchPad. I can close this preview, by the way. I mean, we're not going to really see anything in there that we can see in the actual world. So one thing for this ScratchPad is we need to add our static mesh. So if only this would actually respond, I can press this plus button in here and then select a new static mesh. So then this will give me some options. If you want to bring more nodes in, you'd be thinking, well, I'll just right click and type in the nodes. But those nodes will only be, they're very case sensitive. So what I mean by this is you won't be able to get the nodes for the new static mesh specific to what that can do unless you actually start creating a node from it. So if I drag a node out, I can now look for random try coordinate, which is something that you can only get if you're bringing it from a new static mesh, or basically from this parameter. And then from this one, from the same sort of node in here, we want to get a get try position WS. This is because we're trying to the texture that we're going to apply to our Niagara sprite render will look at the color sample within the texture and will disperse it across the mesh. And that's what we're trying to get right now. We're trying to get the coordinates of the mesh, the UVs of the mesh, for this texture to be applied across it. Okay, and now we just want another point, and for this one we're just going to go get try UV, which you can see here at the bottom. Now we want to get the coordinates of random try coordinates and put them into the coordinates of each of these 2 points, like that. Leave the UV set as 0, and now this position. So we're gonna have to select the map set, press the plus button, add in position, and then press the plus button again and add in a a dynamic material parameter, and then you can plug the position over into the particle position and this one into the particle dynamic parameter, and then you'll get this automatically sorted. And this should really be it. If I compile, there's no error, so that's great. So this is pretty much working as intended now. If we have a look again over into the, to see this system, nothing has really changed because it's time to actually put together the material so we can see those changes. The material itself will need a couple of things doing before we can proceed as well. If we shift control space to bring the content browser, or just get a content browser, it doesn't really matter. I'm going to go back into tutorial, right click and create a material. And we're going to put m_nebula. Okay. We can also right click it and create a material instance, and then with the material instance go into the sprite render over here and drag that in. Drag the material instance in there, and that's fine. Now we'll right click the actual material where we're going to do all of our editing. With the material selected, we can change this over into a translucent domain, and you can leave it as default lit or unlit, it doesn't really matter. Actually, nah, it's fine. Just leave it as default lit. It should be fine. Okay, now we want to bring in a radial gradient exponential. Okay, this is what's going to help us to disperse the texture within our, to mask some parts on the mesh. We then need to bring in a particle color, and we'll leave this about here. We need a texture. So the texture, I should be able to, let me just look for a texture sample. I'm just going to bring a texture sample here, and I'm not going to do anything with it as of yet, but I am going to right click it and convert to parameter, and I'm going to just call it texture. It's fine, that works, because we can drop any texture we want in here once the setup is done. This actually works with any texture that you want as well, by the way. So another thing that we want is a dynamic parameter, and we'll use the first dynamic parameter, and we'll plug that. Well, actually we need to make this into a float, so make float 2 is what we need. So we'll put parameter 1 in the x value, which I'm just trying to do, and parameter 2 in the y value. Then with this done, we can drag the result of these two into the UVs of the texture. We can add a multiply node over here and multiply the particle color, the RGB, into the A value and the texture into the B value. Okay, now we can Control W on this multiply node to make a new copy of it, and in there we can put our radial gradient exponential, and then we'll take the this particle input data from here and put in the A value. This goes into the opacity, and also let me just come up here. We can keep the number 3 on the keyboard pressed and left click on the viewport, and this will bring us a nice color in here. And we'll convert that to a parameter. Just call it color. It does. Oh, I'll call it something else. Color. Okay. Duplicate the multiply again. Take the color into the A value. Take this multiply into the B value and put this into our emissive, because these particles are always going to be emissive type colors. Okay, now this requires a texture. By the way, you know, just dropping a texture in there for the sake of dropping a texture, because it's a parameter, you can replace that texture with anything, but it does require for it to have a texture in there. And luckily enough, if I search somewhere, let me just have a look. I believe I will need a content browser. So content browser, just trying to find a texture. Okay, there we go. So I don't know, should I use that texture? I'll use this one. I'll show you where you can find these textures in just a bit when we get there, but I'm just gonna drop a texture for now. As I said, any texture will work. That's fine as long as you drop a texture into the effect. Okay, now I can just apply this whole thing, and let's just go and find our system that we've created. So F to find it. Hopefully it's somewhere around. Oh, we were in it. It's actually black. Okay, that's fine. We just need to play around with some of the colors now, because we need to set the whole thing up. So let me just get over in here, position my camera a bit. So what you'll notice is that, as I said, it's black. So one thing that we can do is go into the instance of the material that we created, and then change the color, go to white, and press OK, and now you can see that it's visible, but obviously it's not looking right. It's not showing us the correct colors, and mainly this is to do with the sample static mesh and static mesh location, because when we created this in the ScratchPad, it's not actually loading this specific mesh. It's just using the mesh that we've added into the default sample static mesh. So we're going to select both of these and delete them. Press the plus button, and then you can actually search for Nebula, which is the one that we created. And with that done, I mean, obviously you can see this is the ScratchPad. With that done, if we compile now, so with the Nebula selected, actually I think I haven't added the mesh in here, so wait 1 second. Yeah, so the mesh itself is not yet loaded. This is why I need to actually add the mesh within the new static input mesh. So after we compile, nothing really, I mean, if we go, just have to delete it again because I've got to add it. So add the Nebula. You see nothing is showing up in here, and that's because on the ScratchPad we haven't actually pressed apply. So when we do, this loads everything from here into this panel. And in our system overview now, the Nebula does have all these options. And what we can do is we need the mesh over in here. So I'm just going to type in Galaxy. And I believe this is the one. And then over here, I can type in again Galaxy, and that's the one. Okay, and now if we have a look, our particles are spread on the shape that we've made and the color of the texture that is loaded. So whatever texture we loaded into this material, which is up here, okay, if I change this texture to something else, and I'm not sure, I think one of the textures was called like let me just find some other texture as well, just because I want to show you what happens if you load in a different texture. So let me just have a look. Okay, yeah, so I've got a few textures in here. Now, if I drop this texture in, you can see that the color has changed. I'm going to bring another color, which is this. This is like a sun texture, so you can see that the color has changed again. But nothing is really happening with our system because it is currently not moving in any way. So that's where we are going to start bringing in vortex forces and other such parts of this, other such forces that would help us with the shape. So the first one of my favorite is the curl noise force. You add it in and then just press fix issue. I'm not entirely sure that I like that texture, by the way. So let me just bring this texture, which looks nicer. Okay, let me just go back into here. You can see our Niagara system over here on the side. With the curl noise in place, we can now start adding some strength to it, some noise strength. So let's try that amount. As you can see, it's sort of pushing all the particles away from that shape. And then we can do the noise frequency basically helps the shape, so it just increases the size of the curl noise itself. So if you go for smaller values like 100, the curl noise starts in 100 places basically. If you put it at 50, it starts in 50. You put it at 5, it starts in 5 places. So you can see that effect as you're working with it. We'll leave the baking at medium, that's fine. Then we can add a vortex force. So again, press fix issue. The vortex force needs power. And one of the things for me on the vortex force amount is to change this. So press this button over here and change this to a dynamic. So let me just type in float. No, dynamic float. Why is this not showing up in here? Sorry, they changed it from dynamic to random. So it's random range float. And now you have two values. You've got a 0 and a 1. So, well, you've got a minimum and a maximum more like. So let's just try and do a 10,000 to 100,000. And this might be too much. And you can see what's going on. Yeah. Yeah, this is definitely too much. So let's just bring the minimum down a bit and then the maximum down a bit as well. And you've got to, you can see now that the curl noise is being pulled inwards rather than how it used to be. But one other thing that you can do to dampen this effect is to bring in a drag. And what's nice about the drag is that it can help you build a nicer shape. So we can leave the drag at 1 for now, but based on, you can see now that it's no longer destroying the mesh as it, well, the shape as it did previously. And then we can also do a scale sprite size. So if we bring in a scale sprite size, okay, and we can change the scale factor to a vector 2D from curve, and this will allow us to create some parameters for the curve itself. And what I like to do is add another point, add key to node. God, this is too small. Let me just make this a bit bigger. I can select the first point over here and put it at 0, 0, 0, and the other points are 0, 0, 0 as well. I think I've got another point here actually. Let me just bring this forward, and I'll bring this over into here, and then I'll add another point. So you can see we've got 4 points. The last one, it's at 1 and it's 0 value, so that's fine. This one we want to put it maybe at 0.75, and then we put it at 1. This one we'll put it at 1 as well, but the value is going to be 0.25. Something. Oh damn! What have I done? Let me just delete this point. No, actually that point was fine. I think I need to delete this point. I've created 2 curves. I only wanted to work with 1 curve, not 2. So just the red one. And this point I'm going to put a 0.25 and then a value of 1. So we've got 0, 0, 1, 1. Yeah, this is how the scale happens. But I might need to go into the initialized particle and increase the size of our particles, our overall size. I think I may have made them too small. I think I need the green value. So if I select all these points, yeah, I'll need to do the green. I'll need to do the green as well. So let me just add pretty much same curve, same points, and I'm going to put them at the same values as the red. So that would be time 1. It won't allow me to be, there was already a key at the point. Yeah, that's fine. Okay, so we can just put this closer. So you can drag them down if you want, just as close as the other ones. And this will help us to scale the particles and have smaller particles and bigger particles at the same time, which is, I think, is quite nice. One thing that I'm going to do is I'm going to save the scene and log back into Unreal Engine, because I just get FPS problems now, and it must be because I'm doing this recording as well. And we're back into the system, which hopefully won't be causing me any more issues with performance. Okay, now this needs to be bigger. You can see that's massive, right? And this needs to be bigger. So let me just bring this particle away, and I'm just gonna really come out. What's the size of that? That's the size of 100. So, but it's also the size of the shape itself is important, because if the geometry wasn't big, then it doesn't matter how big this is. So it's looking like I need to do like 1,000 maybe. So yeah, it's 1,000 now. It's quite big, but as you can see, there's just not enough particles to hold the shape. So this is where we can go into our emitter properties again, and we can then go into our initialized particles over here. This is the point where we're going to add a bigger amount, which I think that looks okay. So it's a very big particle system. The spawn rate may just not be enough, so I'm just gonna bring that over to a 2. So now we've got more particles being spawned, maybe a 3. So we've got 3 times the amount of particles that we had previously. and that's great. And you can see our forces aren't really doing anything anymore. So this is the point where the maximum and minimum needs to start increasing. So you can see again some movement in there. Maybe have a minimum that's quite... The reason why I'm doing a minimum and maximum is because you can actually choose the evaluation type to every frame. So now every frame that passes, the system is looking to see how fast these particles should be moving at, based on the figure between these two values. So that's quite neat. Let me just have a look. Does that look okay? Again, I think this is very much dependent on the shape. So am I moving too fast now? No, I think I should be okay. Right. So the shape of this whole thing is very dependent based on what kind of a geometry you've created. So that's how this looks like. Let me just try and increase the curl as well. I think the curl might be a bit too strong. See, when the curl is stronger than the vortex, this sort of tends to happen. We could try 50 in size, so the curl isn't as I don't know, hideously looking, should I say that? We'll just bring the vortex a bit higher, maybe to a 2. And you can see that it's obviously pulling inwards in here. You've got some parameters, like you could go and do like a 1-1 kind of thing, so it pulls differently. You can see now it's pulling on all axes, so or maybe we leave it like that. Now if the particle sizes is increased, by the way, so if we go in here into the initialized particle and we move this over to a 2 instead of a 1, it's gonna start to blur a bit. So just bear that in mind. You are going to see a bit of a blur of the particles as you make them bigger. So if you want to keep them smaller, that's fine. At 1, that's also fine. This color mode here is important because you could change this to, let's say, a 10, and then your particles will be red. But if you change everything to a 10, your particles are going to be brighter than usual. You can see they're actually starting to emit light now, which is also an interesting thing. But if you put this to a 0.01, you've now reduced the alpha of these particles. And if you put this to 111, then they're going to lose their shine a bit more. Actually, they look to be invisible at this point. Well, no, they're not invisible, but they're fairly low, they're in fairly low visibility right now. But as I said, you can also go crazy with it and just go to 100, but then the alpha won't really matter as much because you've obviously brightened them up so much. But if you put the alpha now at 1, then yeah, this is what's going to happen, right? This is how much you're getting there. And we could in theory, let me just put 0.05, and we should be able to go at the spawn rate and maybe add some more. So this is now adding 7 times the amount of particles that we did, and you can see it's still moving very, very good at 60 frames. As I said to you, if you are doing recordings and if you need to move from window to window and not have Unreal Engine constantly be in your view, then this was going to happen. Performance will just degrade over time. I think it's a bug, to be honest. I don't think it's intended. And it's definitely not because of the system, your computer. It's just how things are with Unreal Engine 5, I guess. I don't know if this is happening in 4.27. I can't say that I remember that. But yeah, this shape is obviously different from this shape, and if we, for example, would go into the Nebula and change this, let's just type in Galaxy and we'll select Galaxy Taurus 2. That's the mesh that exists within the project file. You can see that it's resembling that, but it's very bright. So I'm just going to go into our initialized particles and change this to a 111, and you can see how that looks like. I mean, the shape of that is just a bit better, but the size is still too small. So you definitely want the size to go even larger. Now this is a very large system, right? This is what you would use in order to create your nebulas, just like those there, you know. So you could have like a planet here. There is, by the way, there is a way. So if we take this particular blueprint, and let me just edit it. If I then go and select the nebula and double click it, you'll see that none of the forces are actually active on it, but instead I have a curl noise in the particle spawn, which makes it so that it doesn't move anywhere. I've also put a drag just in case, but let's just do that. So if we deactivate the vortex and the curl to this particular system right here, okay? Now, you see how it looks without any of these forces applied. If we select on particle spawn, we do curl noise force here, fix issue, and then increase this to something like that. Maybe we need more. I think we need more. So you can see the curl noise is now affecting it, and we could probably change this to a 5 or something. No, 5 is not good. 25 maybe? So it's applying the curl noise. Yeah, see that? But the particles aren't actually moving anywhere, which is very interesting, isn't it? And if I go into the initialized particles and just increase the size, sorry, I'm trying to get there, but so increase the size. Is it a 3? Yeah, 3 seems to be fine. You can see how we've just created a static shape of the same Niagara system that we had. Okay, nothing in here is really moving. The only movement you're seeing is actually just the spawn in and out of these systems. But you know, this looks quite nice for a sort of a system. If you make this larger than what it is right now, you can do something with it in the background of your scene, and it would look quite okay. And that's pretty much it for the main system. You know, the second system that I've got here on this, which I can activate only if I open the blueprint again in the Niagara system. That is just a copy of this, but with far fewer elements being spawned and at a far bigger size. So I'll just quickly do that and show you what I mean. But to begin with, first let's just get the curl noise out and add and reactivate the parts that were making everything sort of move towards the center. Okay, and very quickly copy paste. Well, now we've got 2 systems. This is going to be a bit heavy, so I'm just going, well, I can't deactivate it, but I can go into the spawn rate and put that to maybe 1000. You definitely want to change that very quickly because obviously we duplicated it. And we're going to leave the vortex drag and so on, but then we're going to click the initialize particle. And let's just add a 1, but another 0. Oh, that's a bit too big. I've added another 9 as well. Didn't need to add a 9, did I? You can see them. They're in there. They're quite big. And this bit too many. So let's do 200. And the initialized particle, I am going to really give them a bump. So 10, 10, 10. Okay. See, they're really shiny as well now. Do a 1 here, and now they're really shiny. Yeah, they're actually very nice looking, and because they disappear and reappear as well, you can imagine they'll just blink because of that. Now their size is probably a bit too big still, so I'm just going to take a 0 out and a 1 and instead add a 6. And now they're a bit smaller, and they just make this scene come together a lot better, doesn't it? And you can play around with their vortex force. So instead of having, instead of making them move so quickly, you can change to a 1. so they move slower. But just make sure there's enough velocity there that they actually do move. So maybe change this to a 5. Oh no, sorry, the 5, that wasn't right. So maybe a 2, yeah. Maybe a 2. They're still moving, but not moving fast enough, okay? Look at that. That's a beautiful looking system, isn't it? Yeah. Look at that. Milky Way. Only joking. But yeah, this is more like this looks like a galaxy or a nebula. Nebula not so much. Nebula is like a gas cloud, so I wouldn't say that they're nebulas. I would say more like galaxy. But yeah, that's how you can make them. You can just interpret them. I'm using one to sort of collapse a planet here. I find that's interesting. That's the thing, that's the beauty about this whole process. You can interpret things the way you want them. But that was really it for the tutorial. I do hope you found it useful. I do hope you've learned something. I have definitely learned quite a few things with Niagara systems, just by experimenting with these things and trying to create effects that I would be happy with. And I'm looking at improving them even further. I've actually got a big project that I'm working on in regards to planet space, generating planets and atmospheres and all sorts of things, which I will share with you guys, and I will show you how to make them yourselves. In the future, I will be planning more tutorials, so just leave a like, a comment, and subscribe. Your feedback is greatly appreciated, so let me know what else you want to see on this channel, and I will try and make it. Don't forget, you can join the Discord channel in the description below, and then yeah, you can join the Discord channel and we can talk there. So yeah, I'll see you in the next one.